Let's talk about weighted voting then. That's what we are discussing. Weighted voting. And we started off last time talking a little bit about this. We're going to get into some specific details a little more in detail today. Weighted voting. Remember the basic idea and the example that we talked about last time was how about voters with weights of 12, 10, 5, 1, and 1. This was the example last time. And the quota of 20. So the scenario, if you recall, is there's a bunch of people voting on just like a yes or no decision. There's just two alternatives. And we usually think of it as like people trying to pass a law or something like that. And the weights represent how much their votes count. So for whatever reason, in this system, there's one person whose vote counts for 12. There's one who counts for 10, and so on. And then the quota is how many votes it takes to actually make it happen in terms of like passing the law or whatever. So in this system, those are the weights, and the quota is 20. You need 20 votes in order to get to a result, to pass the resolution or whatever it is you're talking about. And the big thing that we're going to be talking about this weighted voting is just how do you look at these numbers and the quota and determine who in this system has the most power and exactly how the power of the various people are related. Now, from a sort of naive point of view, it seems like the 12 is the most powerful. The 10 is a little bit less. The 5 is maybe kind of a lot less. And the 1 and the 1 each only have a very small amount of power. But that is not true based on what we talked about last time. I hope you remember. In this system, so here, it's not obvious at all, but the 12 and the 10 have equal power. And the 5, the 1, and the 1 have no power. None at all. All right? That says 12 and 10. It looked like a 16. All right? And this is not obvious by looking at the numbers, but if you look at the numbers carefully and you think about what are all the various ways that these numbers could add together to get to 20, the answer is the only way these numbers can add up to 20 is if the 12 and the 10 are both involved. Then you can make it to 22, right? But any other combination doesn't make it to 20. Like the 10 and the 5 and the 1 and the 1, or even the 12 and the 5 and the 1 and the 1, that's only 19, which doesn't make it. So for that reason, the 12 and the 10 are both powerful, but they have to go together in order to make it happen. And so actually the 12 and the 10 have equal power. The 12 is not more powerful than the 10 in this system. And the 5 and the 1 and the 1, there is actually there's no scenario in which those three guys can make any difference at all in terms of making it to 20. And so they have no power. All right, this is complicated, and that's what we want to talk in more detail about. Here's another example. Here's sort of like a real world example, I guess. I don't know. It's not real. I'm just making this up. But let's say my corporation has 4 board seats. This kind of weighted voting is very common in the corporate world. It's actually how things usually work in a company which has investors or shareholders. When they vote, people vote in proportion to the amount of shares that they own, right? And if you own more than 50% of the shares, then you sort of automatically can run the company. But if you own less, you vote according to your proportion of shares. Let's say my corporation has 4 board seats and they have weights 10, 10, 10, and 9. And when they make decisions, the quota is, let's say, 30, all right? This one is not so hard to see if you think for a moment about it. I think you will agree with me if I say, in this case, it looks like, just by the numbers, it looks like the 9 is only slightly less important than these 10s. But because you have to make them add up to 30, actually this 9 has no power at all in this system. Because the only way it can get to 30 is by adding the 3 10s together. And whether you include the 9 or not doesn't make any difference, right? If you had only 2 10s plus a 9, that doesn't make it. So there is no scenario in which this 9 matters. So my corporation, you could ask some sort of realistic question like, would you invest $1 million to become the 9? The answer is no. Being the 9 is worthless in this system, right? The answer is no. In this case, the 9 has no power at all. The 10s each have kind of equal power here to get to 30, but the 9 is not capable of making it to 30. Even though 9 is only, 1 less than 10. On paper, it kind of looks like these are all kind of even, but they're actually not. All right? Strange but true. These situations, we're going to talk about examples like this all the time, and I don't really want to write all of these words every time, so here's just a notation. So that system that I just discussed, this system would be written like, we put this in a bracket, 30 colon 10, 10, 10, 9. All right, so when you see that, this is a substitute for all those words that I just said. So this means I'm describing a system where the first number you see is the quota, and then these numbers, in this case there are 4 of them, but there could be some other number. These are the weights, right? So this is how we're always going to write this system. And so when you see like homework problems about this, I will not be writing all these words. I will just instead write this. All right, or like the example from the beginning, the example from before that would be written like 20, 12, 10, 5, 1, 1. Right? That was a system in which the quota is 20 and the weights go like so, 12, 10, 5, 1, 1. All right, this is how we're going to write down these examples just as a shorthand. So today I want to talk about some very basic power relationships that you can try to identify in a system like this. Maybe I'll give you another example here. So we're going to talk about actually 3 types of basic power relationships. And then next time we're going to get into a more sophisticated way of measuring the power. But for today we can talk about some basic ones. One of these basic relationships is in a system like this. Let's say 10, 12, 4, 3, 2. So here the quota is 10, and the weights of the voters are 12, 4, 3, and 2. And one thing that you will notice is, remember, that's the quota, right? And those are the weights. The 12, the person with 12 here is already exceeding the quota on their own. And this means, basically, in this system, the 12 gets his way all the time because one of the voters here is already exceeding the quota by themselves. So the 12 here exceeds the quota by themselves. That means that none of the other votes ever matter. The 12 can just vote, and if the 12 votes yes, then it's a yes. If the 12 votes no, the other 3 cannot make it to the quota. So the 12 exceeds the quota by themselves, and the others, even if the others all go together, they cannot make it to the quota of 10. Because if the others all go together, it's 4 plus 3 plus 2, which is 9. So the 12 exceeds the quota by themselves, and the others can't add up to the quota without the 12, right? And so that means the 12 as an individual controls everything here. Nobody else's opinions matter, only the opinions of the 12. So in this case, the 12 has all the power. The other guys don't matter at all. And we say the 12, in this example, is anybody know there's a word for this? This is a word we've used before. Yeah? Is a dictator. Yeah, the 12 we say is a dictator. All right? And that's the first of these like 3 basic power relationships. Sometimes your system has a dictator. That is, in democratic voting, this is something we try to avoid, although in this kind of like corporate voting, this is often the case when there's somebody who, for whatever reason, owns a majority of the shares or whatever, they essentially become a dictator. All right, so that's what it's called. And this is, if you're looking at a system like this, this would be a very easy homework question. I show you a system like this and I ask, is there a dictator? It's very easy. The way to tell is just like, are any of these numbers greater or equal to the quota? So it's very easy to identify, easy to see if any weight is equal or bigger than the quota. That means that person is a dictator. If you can make it to the quota all by themselves. So if any weight is equal or bigger, I missed a word, than the quota, then they are a dictator. This is the simplest one to see just by looking at the numbers. You can immediately say by looking at the numbers. All right, now there is an opposite of a dictator. A dictator is somebody who has all of the power. There is also, we have seen examples where there are individuals with no power at all. That has a name also. So the opposite of a dictator would be someone with no power at all. That would be, for instance, like, this one that I just wrote a few moments ago, 30, 10, 10, 10, 9, right? In this system, we decided the 10s all together can make it to 30, but the 9 actually, there is no scenario in which this 9 matters at all. So here, the 9 has no ability to affect the outcome. I think I used the wrong effect. It should be the affect, I think. Is that right? Any effect experts? No. The 9 here has no ability to affect the outcome. So a voter, there's a name for that too, although this is not a word that we've used, but a voter with no power at all, like this 9 in this example. I'm not making this up. A voter with no power at all is called a dummy. That's what they call them, a dummy. All right, so we got dictators and dummies. And of course, often, like this 9 here is a dummy. These 10s are not dictators because they cannot reach the quota alone. But sometimes there are dummies and dictators. So in fact, in that example that I said a moment ago, 10, 12, what was it? 4, 3, 2. The 12 is a dictator here because 12 is more than 10. So that the 12 can meet the quota all by themselves. The 12 is a dictator. And the 4, 3, 2 are all dummies. The dictator has all the power. That means automatically the other 3 have no power at all, and so they were dummies in that system. But in this other one, 30, 10, 10, 10, 9, in this system there is no dictator because none of them individually makes it to 30 all by themselves, but 9 is a dummy. All right. And this would be a typical, homework question. I show you one of these things, and I say, tell me if there's any dictator, tell me if there's any dummy. Dictator is very easy to see. It's just, are any of the numbers bigger than the quota? The dummy is a little trickier. I mean, here you have to think a little bit to realize that this 9 is a dummy. It's not immediately obvious, but you can figure it out if you think for a moment about the numbers. All right. Great. There is one more type. I have a bunch of examples for you all to try in a few minutes, but there is one more type of this kind of simple power relationship. Oops. And this one is a bit more complicated than the other two. So one more. This refers to, here's another example, 12 is the quota. 9, 5, 4, 2. All right. And let's think about how can you get to 12? Now, the 9 here, first of all, is the 9 a dictator? The answer is no. Dictator just means that that person already makes it to the quota all by themselves. So here, 9 is not a dictator. All right. 9 is not a dictator because 9 is less than 12. But there is something interesting about 9. 9 in this example is super powerful because if you consider all the other ones, 5, 4, 2, these guys, if you were to add them all together, that only makes 11, right? So these guys together cannot make it to 12. I would say the 9 is necessary to get to 12, right? That is, the 9 cannot make it to 12 all by themselves, but you cannot get to 12 without using the 9 here, right? The 9 is necessary to get to 12. Another way of saying the same thing, you can't get to 12 without agreement from the 9, right? I'm just saying the same thing again, sort of the other way around. If you want to make it to 12, the 9 has to be on board, right? This means the 9 cannot get to 12 all by themselves, but if the 9 is not on board, it's not going to happen. And there's a word for this, and you probably heard this from politics. We say that the 9 has veto power. All right? That means they can't, the 9 by themselves cannot just make it to 12. But if the 9 is against it, then it's not going to happen, right? You can't make it to 12 without agreement from the 9. All right? So maybe just to say a little bit more formally here. So a voter has veto power when their vote is required to meet the quota. You can't get to the quota unless they are participating, when their vote is required to meet the quota. All right, another way that you can do this, and actually, like, that's the basic idea behind veto power, although from the point of view of like answering homework questions or whatever, another way to try to figure this out, I could ask you who has veto power in this or that example. Another way to figure that out is, I would say, i.e., all other voters added together cannot meet the quota. And this is a little easier to check if you're trying to do homework problems or whatever. So for instance, in this example here, how do you know that the 9 has veto power? It's because if I add up all the others, it only adds up to 11. That means you can't get to 12 without the 9, and so 9 does have veto power. You could ask, is the 5, I mean, the 5 is sort of second best in this system. Does the 5 also have veto power? Do you need the 5 to make it to 12? They are saying no. Yeah, you do not need the 5 in this example to make it to 12 because even without the 5, I could go 9 and 4 makes it to, that's 13, right? So in this example, 9 has veto power. None of the other ones have veto power, right? How about, can we just look again at this one here? 30, 10, 10, 10, 9. Who has your job in these kinds of problems? And you're going to have a lot of homework problems like this. Find any dictators, dummies, or veto power. So I want you to tell me, is there a dictator? Are there any dummies? And are there any people with veto power? So in this one, we've already discussed, there is no dictator. That's always easy. It's just, is there anybody who already makes it to the quota all by themselves? So there is no dictator. What about dummies? We already discussed in this example, the 9 is a dummy because the 9's vote in this example doesn't ever contribute to making it to 30 or not. And then what about the veto power? Anybody see, you should be asking yourself, is there any number over here that actually you need in order to get to 30? What do you say? Yeah. You need the 10s. Yeah, actually like remember this represents 3 different people, each of whom has weight 10. And all of them have veto power, right? You need all 3 of them in order to make it to 20. So the veto power would be the 10, the 10, and the 10. There are 3 voters with weight 10, and all of them have veto power in this system. All right. That's how we do it. So I got, let's just look at, how about one little variation on that, and then I have some for you all to try. Little variation on that. Yeah, here's my variation. This is almost the same, but it looks a little different. I'm going to throw in one more 10. How does that change things? I want dict, dom, veto. All right? Your job is to figure out, again, are there any dictators? Are there any dummies? And is there anybody with veto power? So first of all, dictator. There is not a dictator. That's the easiest one, just because none of the voters themselves make it to 30 all by themselves. So there is no dictator. What about dummies? You should be looking at the 9, just like when we looked at this before. Is it still true that the 9 is a dummy here? That means their contribution can never actually make a difference. I think it is still true. The 9 cannot make a difference in this system. You might add these up to 20 and then include the 9, but you still didn't make it to 30. So the 9 is still a dummy in this system. And what about veto power? You should maybe look at this 10. And the question is this 10 here required to make it to 30? I think the answer is no, because you can make it to 30 using these 3 10s, all right? Now, it is true you have to use one of the 10s, but that's not what veto power is about. Each individual, is any of these individuals actually required to make it to 30? And the answer is no. And you could do away with any one of them and still get to 30, all right? So there is no veto power. This is because no individual 10 is required to get to 30, right? Of course, to get to 30, you do need to use some of the 10s, but there's no single one of them which you need to use every time to get to the quota. All right? Great. I have some for you all to try. So your job for each of these is, do what I just did. Say if there's a dictator, say if there's a dummy, and say if there's any with veto power. So find any dict, dom, vetoes. And I'm just going to give you several examples here. How about 10, 12, 9, sorry. That's an easy one. I'm going to give you a few moments and I'll walk around and see how you're doing. I made all the quotas 10 just for fun. Felt cute. All right, see what you think. Talk to your friends about it as usual. You don't have to talk to your friends, of course. Okay. Mm-hmm. All right. Okay. That's good. All right. Bullets. All right. Mhm. All right. I think you have to. But in that second one, you can make it 10 by doing like 5 plus 3 plus 2. So that 2 actually does matter. All right. Okay. Okay. Yeah. I'll give you a couple more minutes and then we can talk about these. All right, can we chat about them? Nobody wants to talk to their friends today. Maybe you don't got any. That's all right. So the first one, pretty much everybody said. 12 is a dictator. That's very easy to identify. When there is a dictator, then automatically all of the other ones are dummies. This is the state of dictatorships. So that means the 5 and the 4 are dummies, because if the 12 has all the power, the 5 and the 4 have no power at all. And what about veto power? Is there anybody whose vote is necessary in order to reach the quota? What do you say? I think there is somebody whose vote is necessary to reach the quota. I would say the 12. Yeah, some people, as I was walking around, realized anybody who's a dictator automatically also has veto power, because veto power means their vote is necessary to make it to 10, and that is definitely the case here. You can't get to 10 without the involvement of the 12. So this is actually a general fact. Any dictator automatically has the veto power. So if you ever have a dictator, then they also automatically have veto. All right, pretty much everybody said that. For the next one, 10, 5, 4, 3, 2. So the dictator is always the easiest. There is no dictator because none of those equals 10 all by itself. Dummies and veto. What did you say about dummies? You should be looking, when I'm looking for dummies, you should sort of start at the bottom, because those are the ones who might be dummies. The 2, you should ask yourself, is there any scenario in which this 2 can actually meaningfully contribute to make it up to 10? I would say yes, there is. Can you say, I saw some people nodding. How would they matter?
If you did the 5 and the 4, you could add the 2 and that would give.
Yeah, right. If you had 5 and the 4 together, then the 2 actually matters. This would be 9, right? But then whether you use the 2 or not, it depends if you can make to 10 or not. So the 2 can matter sometimes. So the 2 is not a dummy. Do you have a question?
I said the 4 was the dummy because I did the 5 and the 3 and the 2.
The 4, I think the 4 is not a dummy. You did the 5 and the 3 and the 2?
Like to get 10?
Yes.
So I didn't need 4.
Yeah, so what that means is that sometimes the 4 is not necessary. But dummy means the 4 is never important ever, which is not true here because, for instance, if you had 5 and 3 makes 8, then you could use the 4 to either get to 10 or not. So the 4 does matter sometimes, which means it's not a dummy. And the 2 also does matter sometimes, which means it's not a dummy. So here, there is no dummies, right? Certainly, if the 2 is not a dummy, then all these higher ones are also not dummies. You don't actually have to think through every single number. If you're looking for dummies, really, you only need to look at the ones on the bottom. Now, if the 2 was a dummy, then I would want to also consider the 3, but it's not. All right. Okay, how about the veto power? This question is, are any of these ones necessary? Do you need them to get to the 10? Actually, what she just said about the 4 is the correct way to think about, does this 4 have veto power? The question is, do you need the 4 to make it to 10? And the answer is no, because you can do 5 and 3 and 2. We should look at the 5. Is the 5 necessary to make it to 10? I think it is, because if I add the others together, it only adds up to 9. And so this 5 is required to make it to 10, which means the 5 has veto power. I hope that's what you all said. Any questions about that? You do have to look kind of carefully at the numbers. I wouldn't say it's especially hard, but it's, you've got to look carefully at it. All right, the next one, 10, 7, 3, 3, 2. Okay, again, there is no dictator. How about dumbs and veto? So looking for dummies, I would consider the 2. What did you say? Is the 2 a dummy? They're not saying anything. Some people are nodding. I think they're nodding, or there's some sort of tremor. I think the 2 is a dummy because all the various ways that you could add these numbers up, I don't think there are any combination in which the 2 actually matters. If I do 3 and 3 and 2, that only makes 8. If I also throw in the 7, then that would be 15, in which case the 2 didn't matter anyway. I could do 7 and 3 to make 10, and that means the 2 doesn't matter. There are no combinations in which this 2 actually matters. So the 2, I would say, what? I wrote a D. The 2 is a dummy, all right? Now, since the 2 is a dummy, I should also consider maybe the 3 is also a dummy, but it's not, because this 3 can be important in terms of like if I did 7 plus 3, then that 3 really does matter in that combination. And so the 3 is not a dummy, so the 2 will be the only dummy. I hope that's what you all said. And then what about the veto? Any of these have veto power? What do you think? Yeah. Yes, I would say the 7 has veto power. You must use the 7 to make it to 10 because the rest of them together only adds up to 8. So the 7 has veto power. You should also consider, okay, if this one has veto power, what about the 3? Does this also? And I would say no, because if I add together the others, they add up. 7 and 3 and 2 makes 12, and so this 3 is not necessary. So just the 7 has veto power. I hope that these are making sense to everybody. Let's just talk this last one here. Dict, dom, veto. All right, again, dictator is the easiest one. None of these are dictators because none of them by themselves is making it to 10. So there is no dictator. What about dummies? You should be considering the 2. What do you think? Can you show me the thumbs? The 2 is a dummy or is not? I see all the thumbs going in the upwards direction. Great, yeah, the 2 is a dummy because the only way you can make it to 10 really is by doing the 7 and the 3. And the 2 has no effect on anything. So the dummy would be 2. And the veto power, you should look at the 7 and you ask yourself, is the 7 necessary in order to make it to 10? And the answer is yes, because the other 2, 3 and 2, can only make 5. So 7 has the veto power. You should also consider the 3. Is the 3 necessary to make it to 10? I say yes. Also, the 3 has veto power. And you should consider the 2. Is the 2 necessary to make it to 10? No, because the other 2 can add up to 10 without the 2. So the 2 does not have veto power. There you go. 7 and 3 have veto power. 2 is a dummy. All right, I hope that those sound manageable to everybody. Any questions about that business? This is dictators, dummies, and veto power. All right, great. We got 10 minutes left. That's enough time to say one more thing, and then maybe I'll start talking about the next thing. I wanted to, as a very important example, I mentioned this last time, sort of like in our in American politics, we don't usually use weights on our voting. Like in typical democratic voting, everybody's vote is the same weight. Otherwise, it's not very democratic. There's no time in our voting in real life when like my vote counts double because I'm older than you or something like that. So there are not weights typically, but there are. You can view one of our major political systems in terms of this weighting, and that is, I mentioned this last time, that is the United States Electoral College. This is an example of a very important weighted voting system in our politics. Remember how it works is each state, individual people vote for the president, but actually your individual vote doesn't count for the presidency. What counts is the state-by-state votes, and each state has a weight according to its population. And I looked up the numbers here. In order to win, you need 270 to win in our current system, the way it is right now. If you were to write this in the way that we typically write these weighted voting systems, you put the quota first. That's how many electoral college votes you need to win to become the president. And then you list out the weights. And there's 50 of them or so. Each one of these represents one of the states. I'm not going to write them all down. But all the way at the end, there's like a few threes. 3 is the least that you can, for the states, 3 is the smallest amount of electoral votes that's possible for a state to have, because each one is the number of senators plus the number of Congress representatives. And everybody gets 2 senators and at least 1 Congress. Anyway, this is the state of California. This is Texas. This is Florida. All right. We can ask about this system also the same question about the dictators, dummies, and veto power. So in the Electoral College system, are there dictators, dummies, and veto power? I will just mention, like, these numbers are determined according to the Constitution by the populations of the various states. And these numbers actually change from election to election. Actually, they change whenever we do a new census. They remeasure the population of all the states. And, usually they don't change, but sometimes when they recount the populations, they have to increase one and they have to decrease some or whatever. So these numbers are not sort of fixed forever. They, like California right now, happens to be the most because they have the most population. But populations can change over time, and these numbers will change over time. Anyway, is there a dictator in this system? The answer is no. That's easy. None of these by itself makes it to 270. So there is no dictator. No. What that means, like in real life, if you're talking to your friends about weighted voting and the Electoral College, your interpretation of this to your idiot friends who don't know about this is there's no dictator in the Electoral College. What that means is, like, it's not like the entire system is only based on the opinion of one state. If that were true, then that would be unfair, right? There are people who think the whole system is kind of unfair, but this means that no one state controls everything, right? Obviously, no. I mean, it would be intolerable for most Americans if that really were the case. Like, if it was the case for some reason that California is the only state that matters, they can just decide the president on their own. What that means basically is anybody outside of California, they can vote, but their vote doesn't matter for anything. And this is absolutely not true. All right. So there is no dictator in this system. That means that no one state controls everything. Are there any dummy states? Any thoughts about that? You should be considering, like, these threes here, right? These are like Delaware is a 3. Is that a dummy? 3 is far less than 54. Any thoughts? Show me the thumbs. Delaware is a dummy? Is not a dummy? I see a mixture of thumbs and some people unwilling to commit. I think the correct answer is this. Delaware is not a dummy. There are no dummies here. If you just think about what it would mean. Now, of course, the numbers are complicated. It's not obvious that this is the correct answer based on the numbers. I didn't even write all the numbers here. But think about what it would mean if I told you that Delaware is a dummy. That means the votes of the people of Delaware can never influence the results of the election. That's just not true. Like, Delaware only counts for 3 votes here, but there really are situations when all the other votes could be essentially tied, and then Delaware, those 3 would make the difference between who wins and who loses, right? Like, I believe in the Bush versus Gore election, Bush only won by 1 electoral vote. That means if Delaware had switched, then the result would have been the opposite. So Delaware is not a dummy. And you can imagine, if one of our states was a dummy, that means the people in that state, they can vote if they want to, but their vote actually doesn't matter for anything. And this is not allowed. I mean, that system would immediately be changed if that was ever the case, because everybody's vote is supposed to count for something, right? Okay, great. So what this means is votes from all states could potentially matter. Right? Now, in practice, probably in a typical election, probably Delaware's vote doesn't really make a difference because it's only 3, and usually people win by more than 3 in the Electoral College, right? But in theory, like mathematically speaking, there are situations when even those 3 from Delaware could make a difference. And so there is no dummy in this system. And what about veto power here? You should be thinking about California. Remember, veto power means, say in the case of California, it would mean that you must have California on board in order to make it to 270. Is that true? The answer is no. So this one also is a no. And these are all, sort of all of these no's, I would say for the sake of, American democracy, it's a good thing that all of these answers are no here. So this no means that no one state is required in order to become the president. That's just not true. Right? Like Biden won California and he became the president, but Trump, when Trump became the president, the first time when he actually won, he didn't win California, but he still became the president. So California is not necessary in order to become the president. That's why California does not have veto power, and neither do the states with lower numbers. All right, all of these no's are good. One interesting fact, though, about the way that the system works, like I said, these numbers change over time based on populations, and there is no rule in the Constitution, like this whole system is described in the Constitution, but there is no rule in the Constitution about dictators. Like, it could be, over time, the state population shifts so much, it is, in theory, possible that, like, this California vote becomes so big, if more and more people move to California, California may, at some point in the future, become a veto power in this system. Or even they could, in theory, California's population could exceed 270 all by themselves, and then California would be a dictator in this system. That is technically allowed in the Constitution. I think if that actually did happen in real life, the Constitution would immediately be changed to fix the system. But strange but true fact. All right, that'll do for today.